People often step into an airliner's cockpit and say, how can pilots possibly remember all these instruments? The truth is much simpler. Pilots don't watch every instrument all the time. Some instruments are checked only occasionally. Others are used only in specific phases of flight. Many don't require constant attention at all. If something goes wrong, they warn the crew themselves. Modern computers now monitor thousands of parameters automatically. Yet a few indications have survived every technological revolution. Today, they may appear on a computer screen instead of a round dial, but they still demand the pilot's constant attention. The attitude indicator and the airspeed indicator. Why these? Let's start with the attitude indicator. Everyone knows that angle of attack can become critical. When it does, lift drops dramatically. That can be fatal. But can the aircraft attitude become critical? There is no officially defined critical attitude, no specific pitch angle, no specific bank angle, and yet, yes. Not because of a particular attitude, but because the airplane can lose its sense of orientation. The attitude indicator is often called the artificial horizon, but the horizon is really just a convenient picture. The pilot doesn't actually need the horizon. The pilot needs to know where down is. Even a child knows what is most dangerous for an airplane. It can fall, and the force trying to make it fall is gravity. That is why the pilot must always know where gravity is. On the ground, that seems obvious. We all feel where up and down are. At least we think we do. The first instrument pilots quickly discovered that they could not always trust those feelings. Even in daylight, inside clouds with no visible horizon, pilots lost spatial orientation. The reason is surprisingly simple. Our senses cannot distinguish gravity from acceleration. They respond to both at the same time. During flight, acceleration may even become stronger than gravity itself. Acceleration constantly changes. Its magnitude changes. Its direction changes. Gravity does not. It remains the only reliable reference. That is why the attitude indicator was created, not to display the horizon, but to preserve a reliable reference when the human body becomes unreliable. Originally, the instrument was aligned on the ground using gravity as its reference. Then the gyroscope maintained that reference while the aircraft maneuvered around it. The technology has changed dramatically. Mechanical gyroscopes evolved into laser gyros. Laser gyros evolved into inertial reference systems. Today, the display looks completely different. The purpose does not. The pilot still needs to know where down is. Now, let's look at angle of attack. If it is so important, why don't all airplanes even have an angle of attack indicator? Because aviation learned to control angle of attack long before dedicated angle of attack indicators became common. The solution was already there, the airspeed indicator. Despite its name, it does not actually measure speed. It measures dynamic pressure. Essentially, it is a pressure instrument, a descendant of the pitot tube, ancient pitot, still doing its job. For a given aircraft configuration, dynamic pressure is closely related to the available margin before the critical angle of attack. Pilots may not see angle of attack directly, but for generations they have been taught to respect what the airspeed indicator is really telling them. That is why pilots have an old saying, better lose than airspeed on the fourth turn. We'll leave the missing word out. This is a family channel. The fourth turn is where several factors come together. The airplane is already flying close to its minimum approach speed. It is banked. A bank reduces the vertical component of lift. To maintain altitude, the wing must produce more lift. At low speed, there is only one practical way to do that. Increase the angle of attack. Now, the safety margin is very small. A little too much bank, a little too little speed, a little too much back pressure, and the wing may reach its critical angle of attack. This is where both stories meet. The attitude indicator tells the pilot where the airplane is relative to gravity. The airspeed indicator helps protect the airplane from reaching the critical angle of attack. Different information, different instruments, the same flight, the same gravity, the same physics. So, which one is more important? That was never really the point. A pilot cannot choose between knowing where down is and knowing how close the wing is to its limit. One keeps the airplane oriented, the other keeps the wing flying. Technology keeps changing. Physics does not.